Welcome to Task 3 of Unit 4, Accelerated Math 2. In this task, finding roots of higher order polynomials, you'll be exposed to and taught and shown and expected to use synthetic and long division to find the roots or solutions or zeros of polynomials. For instance, in these first four, you won't be able to factor them. I will tell you you can factor the second one. That's going to be easily found to equal x plus 8 and x minus 8. Now that I look at the second one, 7 and 2 make 14, and 7 and 2 can also make 5. But that needs to be an x minus 7 and x plus 2. Now there certainly might be other factors of those quadratics, but if you run into any issue, you can always use quadratic formula, and that's right here. So with negative b plus or minus square root of b squared minus 4ac all over 2a, you can find the solutions of any quadratic, especially later on once you start getting into long division and synthetic division. If you get down to the quadratic, go ahead and solve that thing. But always remember, as you should have seen in math, actually this is math 2, accelerated math 2, and also for the math 3 students, with the discriminant, just the part underneath the square root. If you ever had a discriminant that was greater than 0, you had two real roots. If it was equal to 0, you only had one. And if it never touched 0, being that it was less than, that means you had two imaginary roots. And if you're not sure what imaginary roots are, you might want to go back and review. So in order to use the quadratic formula, because you're certainly going to need to use them here, or use it here, that's your A, that's your B, and that's your C. Again, it's just the number in front of x squared, just the number in front of x, and just the coefficient that's sitting there by itself. Oh, I pushed the button and it's locking my screen up. Alright, there we go. Anyway, now we're going to take a look at some higher order polynomials, meaning the cubic, the quartic, and the quintic. Now, there's certainly some talk about long division, etc., but I'm going to get a chance to show you how you would actually use long division to divide x minus 2 into x to the third plus 2x squared minus 5x minus 6. Now, I didn't check to see if the example below, no, that's a different one. But let's go ahead and take a look at that. X minus 2, and we're dividing it into, 4x to the fourth, 3x to the third, negative 7x to the second, and negative 4x minus 9. So let's take a look at how this happens. The x goes into 4x to the fourth. Actually, let me give you a whole nother problem. Let's go to my blank page. Give me a second. Open blank. I don't see. There we go. Alright, so let me maximize my screen. So let's say we started out small. And I'm going to show you this one just so that you know how to do it. So we're going to go with x plus 1. And we're going to... Ooh, that's bad. I don't know how I did that. We're going to... That's bad too. Hold on a second. So let's say we go x to the second plus, well, let's go x to the third. X to the third plus 2x squared minus 8x plus 1. Let me show you what long division is. Alright, so x goes into the x to the third. Well, twice, because x times x to the second is going to make x to the third. Notice, I put the x to the second above the square. Now we're going to take this x to the second times x and get x to the third. That's important because x to the third and x to the third cancel out. That's of great importance in long division. Now, again, we did x to the second times x, but we also need to multiply x to the second times 1. That's going to be plus 1x squared. You don't have to write the 1. But we're going to put this expression in parentheses and subtract. That's very synonymous or very similar to what you did in long division when you're working with numbers. Now we're working with polynomials. So, x to the third minus x to the third cancels out. Okay, that's great. Now 2x squared minus 1x squared is just x squared. And then we drop down the negative x or negative 8x. So x goes into x squared. Again, this x goes into x squared and makes x, or we just get x. And x times x is x squared. But then we also need to multiply the x times 1, and we get plus 1x. Put it in parentheses, and we're going to subtract again. Again, of great importance that you have your x squared minus x. That cancels out. And let me draw the line. And you have negative 8 minus 1. That makes negative 9x. And we're going to drop down the 1. Plus 1. So, x goes into negative 9x and gives you negative 9. Negative 9 times x is negative 9x. Negative 9 times 1 is negative 9. If we draw a line, just going to scroll down a little bit. 1 minus negative 9, just so you can see that, 1 minus negative 9, that equals plus, negative makes a positive, 10. Now in this case there is a remainder. So you would write plus 10 over, what did you try to divide into the cubic? 10 over x plus 1. Now I'm not saying you'll always have a remainder. In fact, you should not have a remainder with most of these problems, as long as you do them correctly. So let's continue on. Synthetic division, as you can see, is a little bit different in terms of what you see in doing the division. And some people would say synthetic's a little bit easier, but there's one catch. Notice how we were using x minus 2 in the previous example, but now we're using positive 2. Again, if you set x minus 2 equal to 0, add 2 on both sides, you'll get x equals 2. So now you actually have to use the roots rather than the factors. One of the key features or characteristics of synthetic division is the process. So what you do is you drop the first number. Again, this is the first term. In that polynomial, that quartic, the first term is 4, so we drop the 4 and multiply the root times that number. 2 times 4 makes 8. And so we're here. Negative 3, the second term in the polynomial, plus 8 is 5. Then we multiply that root, 2 times 5, and get 10. Find the sum, like we did in previous steps, and we get negative 7 plus 10 equals 3. 2 times 3 is 6. Negative 4 plus 6 is 2. 2 times 2 is 4. And negative 9 plus 4 is negative 5. Notice there are no remainders. And once you find another root, then you would continue the process. Say in this case you use 5 and see if that works. But again, there will be a way that we show you how to find the perfect roots. Now all of that explain the process. Again, you want to check. So say in number 11, you would choose the root of x plus 4, which is negative 4. Your first term is 3, your second term is, first term is 1, your second term is 3, the next one is negative 10, and the next one is negative 24. And using synthetic division, you drop, multiply, add, drop, multiply, drop, multiply. That's a 6. And continue on. I'm not going to do any more. Now, as we start talking about the rational root theorem, what this says is, hey, you need all the factors of your last term, more or less the coefficient. And notice how it's it's 20. So all the factors of 20 are, for instance, 1, 2, 4, 5, 10, and 20. The other factors for your first term are just 1. Now, if they were more, for instance, in this case, like for instance, if you're going with P and Q, this case would be 1 over 1. So 1 is a potential factor. but it would be 1 and negative 1. What about 2 over 1? And again, the only reason it's saying over 1 is because there's only one digit. So it'll be plus or minus 2. And then 4 over 1, plus or minus 4. I should have just did plus or minus 4. And then 5 over 1, plus or minus 5, and so on. But let's turn to my blank page, and I'm going to show you what your other roots could look like. So say you had x, well let's say 2x squared plus 5x minus 3. Your factors for 3 are, sorry about that, 1 and 3. Your factors for 2 are 1 and 2. So pretend that's your P, pretend that's your Q. Again, P is your last number, Q is your first. So your factors could be positive and negative 1. Also, positive or negative 1 over 2. That could be a factor. And positive or negative 3, because it's 3 over 1. And positive or negative 3 over 2. Now, the quickest way to check if these values are actual, solutions, is if you plug them back in. And if you use synthetic division and get no remainder, you found a winner. Of course, the task tells you that. But you'll probably only understand that with practice. So I'm pretty sure with some of these here, we can find all the factors. But again, they give you some practice. You have to remember in like number 22, you see how they have 4x to the third? There is no x squared, so you have to say 0x squared. And then minus 7x plus 3. Okay? You have to always fill in the gaps. And then I think you should be okay. Just remember, it's all the factors of the last digit, or the last term, over all the factors over the first. And if you have, let's say you have 5 factors on the last term and 2 factors for the first, you're going to have 10 different solutions, or 10 different possible solutions. So you have to run it. Later on in the task, they say you might have imaginary solutions. So, that's certainly something you need to work with. For instance, like 2i. Now, I'll start you off on it. So let's say we go back to my blank sheet. Again, I'm not going to do many steps. But let's say we were working with a problem, and we had 3i as a possible solution. Say we had 7, 6, and 3. So I'm going to drop the 7. 7 times 3i would be 21i. And 6 plus 21i is a complex number. But then you multiply the 3i times the 6 and the 3i times the 21i. 3i times 6 is 18i. 3 times 21 is 63. But I times I is negative 1. So that's going to be negative 63. So you would keep going from there, and so on, and so on, and so on. Again, this would be 18i minus 63. But most of your questions that have imaginary solutions are certainly more than just 3 terms. Again, that's term 1, term 2, term 3. And you'll find that whenever you do have an imaginary solution, especially in your practice throughout the task, all of the problems should have no remainder. So if you're getting a remainder, you're doing something wrong. I meant to draw. I don't know why it's not showing that. Okay, there we go. If you're getting a remainder, you're wrong. If you have any questions, please be sure to ask your teacher. And again, I wish you the best in your course. Good night, or good morning, or good afternoon.